we are introducing something new. Polar coordinates. Okay? Polar coordinates are coordinates that basically, if you kind of glance what you're seeing down here, we're going to graph them basically on a unit circle. Okay? So we've talked a lot about the unit circle. We've talked about the measurements around the unit circle, right? What we haven't talked about are these rings. And those rings have to do with graphing polar coordinates. Okay? I will tell you, I don't think it's in this lesson. I think it's in 6.5. Polar coordinates, there's also, you know how you changed to parametric mode the other day on your calculator? The next mode over, I believe, is polar. Okay, so when we talk about graphing equations, we'll talk about using the polar mode on the calculator as well. Okay, now, so polar coordinates are of the form r, comma, theta. Okay, where r is in terms of what we'll say radius, and theta is your angle on the unit circle. Whereas rectangular coordinates, what do we normally think about for rectangular coordinates? The ones you've been learning since elementary. Those are of the form x, comma, y. And a big portion of what we're looking in this unit is in this lesson, is how to graph polar coordinates, but also we're going to be looking a lot at the connection between your rectangular coordinates, your x, y, and your polar coordinates, your r, theta. Okay? Now, we have 4 relationships between rectangular and polar coordinates. Okay, so in other words, if you know x, y, or if you know r, theta, you can use them to find the other. One of which is x is equal to r times the cosine of theta. Now, if x is equal to r times the cosine of theta, what about y? Y equals r times sine of theta. Okay, that shouldn't surprise you too much, right? Thinking about ordered pairs. Tangent of theta. Well, what if we talked about tangent of theta being equal to? In terms sine over cosine, turn that into x's and y's. Or in other words, if she says sine over cosine, we're talking y over x. Okay? And our last connection is essentially Pythagorean theorem, but we're going to look at this all in a triangle. R squared equals x squared plus y squared. We've used that connection a little bit when we were drawing our right triangles, when we were first trying to find our trig relations, right? So r squared equals x squared plus y squared. Now, the graph of these relations. Visualize, so I'm going to call this point P, okay? With the idea of point P, okay? Your theta is the angle the graph is going to make there with 0. Okay. If we're connecting in terms of x and y, realize, what do we often do with theta? We often create a triangle here that is a right triangle. Okay. And with that right triangle, along the bottom is how far you move right, which is your what kind of value? X. Along the bottom is how far you move right. Along the right side is how far you move up, which is your y value. And where's r? R is your radius, which is your hypotenuse. So thus you can see x squared plus y squared equals r squared. Tangent of theta. Well, tangent is opposite over hypotenuse. So y over x. Let's see. In rectangular coordinates, this horizontal axis is my x-axis, and this vertical axis is my y-axis, right? Old news. And the point P would be the point x, comma, y. Now, we also are going to talk about as a polar coordinate, which means Point P could also be the point R comma theta. We've already got theta and R on our paper. Let's see. X-axis is what we've grown up knowing. That's rectangular coordinates. This axis is also called the polar axis in polar coordinates. Okay, so it's the piece right here. When we get down here, your polar axis is that piece right there. Okay, that's your polar axis. Okay, the origin. The origin we know as the origin. We know it as the ordered pair 0, 0. You'll often see it called point O, as in the letter O. In polar graphing, it is also called the pole. Okay? So just a whole bunch of connections I'm trying to share with you there. Okay. I have this somewhere on the next page too, but polar coordinate plane looks like this, and I'm going to move my page here in a moment, but the dark line is called the, and then I drew it in, but that's what we just talked about calling it as the polar axis. Okay, and so when we talk about the polar axis, my definition of it is the ray that goes from point O. So it's the ray from O, from point O, I guess, or from 0. So it's the ray that goes from the center. And then we just talked about this as well. The center is called the pole. Okay, or what you would have known more likely as 0, 0 or point O. Okay. Got it? So I'm going to change screens so that we have all the information we need. Because one of the big things we're going to do is we're going to learn how to graph these today. Okay?
This is easy. It looks okay.
It's okay, yeah. It's not bad. I would say working with doing the transitions on the back page are probably more, you know, more difficult than just graphing. The graphing isn't bad. Okay. So, okay. I have my graph here. You guys already have that filled in. Plotting points. Now, before we can plot points, I gave you a nice blank grid, didn't I? So let's go through and put some labels on here. And this is something that is helpful to look at. We know 0 is there, yes? Now, can we label the big 4? If this is 0, what else do we know? Up top is pi over 2. Out left is pi. Down low. That's old news, right? Now, I struggle with finding good grids sometimes. You know, you can search polar coordinate or polar grids, and you can get a bazillion of them, but I still couldn't find exactly the one I wanted. But we're going to make do with this one. Now, between 0 and pi over 2, what are the angles we normally talk about? Okay, pi over 6, pi over 4, pi over 3, yes? Now, notice, how many lines do we have here?
5.
We've got 5 lines. She only named 3. If you look at the one on the sideboard in the classroom, we used those middle 3, didn't we? We didn't use what would have been pi over 12 and 5 pi over 12, or in other words, what would have been 15 degrees and 75 degrees. Those aren't big ones we talk about. So what I'm going to label here is I'm going to skip that first line. This is pi over 6, pi over 4, and pi over 3. Yes, you could say 30, 45, and 60. However, if you haven't noticed, polar coordinates tend to work in radians most of the time. Okay? Now, work with me here. Let's just practice a little bit. I mean, I know you can copy down your labels, and some of you may have already done that, but in this first quadrant, pi over 4 is in the middle, yes? So think with me. This is 1 pi over 4. 2 pi over 4 is at pi over 2. What's next in the middle of quadrant 2 over here? 3 pi over 4. Yeah, just count with me. 1/4, 2/4, 3/4. What's next? Pi is 4/4. So what's down here in this quadrant in the middle, down in quadrant 3? 5/4. 6/4 is 3 pi over 2. What's next? 5/4, 6/4, 7/4. And I'm not going to label it, but that puts us at having 8/4 at 2 pi or at 0, yes? These are ways you can label this unit circle without just copying it down if you need to. Okay? Now, that was breaking each, we broke the top half into fourths and the bottom half into fourths, yes? Okay? Let's do thirds. Okay? Up here we have 1/3. That is a third of the top half. Where's 2/3 going to be? Well, 2/3 is going to be the same distance from the x-axis in the next quadrant. 2/3 is right there before 3/4. Okay, that's 2/3. Because think with me, here's 0. 1/3, 2/3. What's here? Pi is 3/3. Now, what's that means going on down below? If that's 3/3, down here I have 4/3, and that's going to be a third of the way around the bottom, so that's going to be past 5/4. That's 4/3. In quadrant 4, we have 5/3, which is right before 7/4. And then 0 or 2 pi is 6/3. Your thirds are always farther from the x-axis than your sixths, right? Now, that just leaves our sixths to fill in, yes? Okay. So the sixths, we're going to break the top half into 6 pieces. So basically, you're counting every 2 lines. So here is 1/6, right? Go 2 lines more. Now I'm at 2/6, which we already have labeled as 1/3. Go 2 lines more. Now I'm at 3/6, which I have labeled as 1/2. 2 lines more. 4/6, already reduced. 2 lines more. 5/6. So there's 5 pi over 6. I actually had to label one. 2 lines more, and now I'm at 6/6. We do the same going around the bottom. So going around the bottom, 2 lines more, and I'm at 7/6. 2 lines, and I'm at 8/6, which is 4/3. 2 lines more, and I'm at 9/6, which reduces to 3/2. 10/6 reduces to 5/3. And 11/6 I have to write in. And then 12/6, of course, is 2 pi. Okay, I'm not saying you have to know how to be able to label this on your own for a quiz or a test or anything. It'll be labeled. That's a good practice routine there. Okay. Now, are we ready to plot points? In order to plot points, note what it says here. First, plot the theta, then the r. Normally in an ordered pair, you go x, y, right? Here, we're going to go theta r, even though our ordered pair is in the form r theta. Okay? So these are r theta values. Okay, So for point A, 3 comma 2/3. First, you find 2 pi over 3. So where is 2 pi over 3? Okay, so 2 pi over 3 is right here. This is why we labeled, yes? Now I don't do anything, but I find that angle. This 3 says a radius of 3. Or you count out how many rings? 3 rings. Okay, each ring has a unit of 1. So I'm going to be on the 2 pi over 3, and I'm going to count out 1, 2, 3 rings. That is point A. Are we okay with that? Okay. Okay, B. 4 comma negative 3 pi over 4. Change it up right off the bat on you and make you think. So, first of all, plot the angle. Where is negative 3 pi over 4 going to be? No. So 3 pi over 4, positive 3 pi over 4 goes up and around counterclockwise and ends right here, yes? What's a negative 3 pi over 4 do? Starts this way and goes backwards, or in other words, it goes clockwise. Where are we going to land if I go a distance of 3 pi over 4? Right here at 5 pi over 4. So another name for this is also negative 3 pi over 4. Fair enough? So now what? On negative 3 pi over 4, I'm going to count out 4 rings. And that is what I have labeled as point B. The origin is 0. The first ring is 1. Does that answer the question?
Yeah.
Unless I counted wrong.
I didn't know.
Yeah, no, your pole is 0. And then, so if my pole is 0, then here's 1 ring, 2 rings, 3 rings. That's the 4th ring. Okay?
Yes.
Okay, what about C? This one's like super easy in comparison. 1 comma pi over 4. So what are we doing? Going to pi over 4 and going to the first ring. And that's point C.
That was easy peasy.
Too easy, right? Okay, D. Negative 2, 7 pi over 6. So, what do I find first? Okay, 7 pi over 6 is right here, yes?
Yes.
Negative 2.
So you go like backwards from the origin?
Backwards from the origin. Yeah. So, a negative 2 says instead of going out 2 rings on 7 pi over 6, you're going to go backwards through the pole. That negative 2 is going to reverse your direction. And so now, I find this graph hard to follow. It's not normally this hard to follow, but 7 pi over 6 lines up with, look at it this way, 2 lines into that quadrant. So it lines up with pi over 6. 7 pi over 6 and pi over 6 are the same line. Does that make sense? So if it says 7 pi over 6, I'm on that line. Negative 2 says instead of going out 2 on 7 pi over 6, I'm going to go backwards 2, which puts me at a positive 2 on pi over 6. This is where it gets kind of fun because one ordered pair, maybe fun's not the right word, but one point does not have just one name for it. Does that make sense?
Yeah.
Like this, we were asked to graph 7 pi over 6 and negative 2. We also could have called that, well, what angle are we on? We're on pi over 6 out positive 2. That's another name for point D. And that's what we'll get into on the next page. Okay? Are you ready for E?
Yes.
Got negatives on both now. -1, negative pi over 3. Start with your angle. Where's negative pi over 3? Okay, so instead of going up pi over 3, I'm going down pi over 3, and so that puts me at 5 pi over 3, if you will. What's -1 say? Go backwards 1 through the pole, which puts me at 1 on 2 pi over 3. Okay, so another name for this could be 1 comma 2 pi over 3 if you want. It's not that you have to write those other names, but I'm just trying to make the connections for you. Okay. Ready for the back page?
Again, one.
Okay. Top of the back page. We are being asked to convert back and forth. Okay. Here's polar coordinates, make them rectangular. Here's rectangular, make them polar. Okay, so a little bit of quick reminders from the front page. A polar coordinate is of the form r theta. A rectangular coordinate is of the form xy. Yes? These are just reminders so I have them in front of me. And then we're going to need those 4 conversions. So I'm going to write them down real quick so we don't have to keep flipping. Those 4 conversions. X equals r cosine theta. Y equals r sine theta. R squared equals x squared plus y squared. And tangent theta equals y over x. Not that it matters what order, but I reverse those 2 from what I have on the front page, don't I? It's fine. So those are the conversions we're going to be using. Okay, you ready for 1A?
Yes.
1 says the polar coordinates of a point are given. Find the rectangular. So if the polar coordinates are given, this is of the form r theta. What are we being asked to find? xy. So we know r, we know theta. Our job is to find xy. Okay, so we're looking at our conversions. If we know r and theta, could we use x equals r cosine theta to find x? Okay, so x equals r cosine theta. X equals 5 times cosine of pi over 6. Yes and no. I don't remember what my answer key has. I have both on here. We're going to talk about both just because it's a good opportunity to. What do you guys remember, or what can you observe about cosine of pi over 6? It's the square root of 3 over 2 according to my chart, yes? So one way to do this is to say 5 times the square root of 3 over 2. I honestly don't remember what the answer key does for answers. But you could leave this answer as 5 square root of 3 over 2. That is an option. Now, I will say, I do have the decimal next. So, grab your calculator and get the decimal answer. I don't see many decimals in homework, though. What is this as a decimal, though? Use your calculator. I I have it both ways, I guess, here, don't I?
4.33.
Okay. Now, did you get 4.33? And I asked that because what mode should you be in? Radian mode. Okay, we're back to changing that mode button around, aren't we? Okay. So there's our x coordinate. What about y? Y equals r sine theta. So y equals 5 times sine of pi over 6. 5 times, what is the sine of pi over 6? 1/2. 5 times 1/2. Well, if I'm matching the radical form, it's 5/2 if I keep it as a fraction. Or what is that as a decimal? 2.5. If you type in 5 sine pi over 6 on your calculator, do you get 2.5? You do, okay? And I just realized on this last one I said what is as a decimal. Did you guys type in this or did you type in this?
5.
So if you typed in 5 square root of 3 over 2, you got 4.33.
Yeah.
What if you typed 5 cosine pi over 6? Would you also get 4.33? If you're in radian mode, yes. Okay, so that's a good check. Did you do things right, isn't it? So, rectangular coordinates, you could write it as one of two ways. We could say it is 5 square root of 3 over 2, comma 5/2, or it is the decimal 4.33, comma 2.55. You can do a quick check. Does this logically make sense? Where would pi over 6 or 5 comma pi over 6 be? Pi over 6 would be where? Quadrant 1, yes. Out 5, there's my random out 5. Does that make sense for 4.33 comma 2.5? Right 4 up 2.5? I mean, the placement makes sense. You can't, we're not measuring exactness, but the placement makes sense, which is what I'm asking, suggesting that you check. Okay, B. A little bit different, so I still want to look at it. -6, negative pi over 2. Technically, I could argue we could do this one without formulas at all and just look at the graph, but let's start here. So this is my r and theta, yes? X is r cosine theta, so what's x going to be? -6 times cosine of negative pi over 2. Well, where is negative pi over 2? That's at 3 pi over 2, yes? The ordered pair down there is 0, -1. So what's the cosine? 0. And -6 times 0 is 0. Y equals r sine theta. -6 times sine of negative pi over 2. Well, were you guys with me? It was right down here, yes? And so that is negative pi over 2, which is the ordered pair, 0, -1. So what's the sign? -1. -6 times -1 is 6. No other form to express this as, right? What is this ordered pair? 0, 6. Can you logically check this to see if it makes sense? Negative pi over 2, -6. Negative pi over 2 is right here, yes? What's -6 do?
Lose out
Goes out 6 from the origin, but since it's negative 6, it's going to shoot me back through the pole. Does that match up with the ordered pair 0, 6?
Yeah.
Okay, are you seeing the connection I'm trying to show here? A polar coordinate and a rectangular coordinate, they're going to overlap. They're going to be in the same physical location, just on 2 different grids. Okay, so that was going from polar to rectangular. What do we have to do now? Rectangular to polar. Okay, so the rectangular coordinates of a point are given. That means, what are these values? We are given x, y. We're trying to find r theta. Okay. Well, if we're given x, y, what do you think we need to do?
R squared equals x squared.
Yeah. Are we using the other conversions now? We are. So, r squared equals x squared plus y squared. Oof, we have to do some math. Negative square root of 3 over 2, quantity squared, plus 1/2 squared. Okay. Square root of 3 squared. I'm not using a calculator right now. Square root of 3 squared. 3. You square root, you get what's under the square root, yes? Square root of 3 squared is 3. What's 2 squared? 4. It's not under the radical, it's just 4. What's a negative squared? Positive. So the first piece is 3/4? Yes?
Yeah.
Okay, what about 1/2 squared? 1 squared over 2 squared is going to be 1 over 4. And what is 3/4 plus a fourth? 4/4, which is 1. What does that make r? Okay. Square root of 1, because we take the square root of both sides. The square root of 1 is 1. There we go. I just had to look around and indicate I wasn't happy with your final answer. R is plus or minus 1. Okay. We have 2 R values. We'll judge how to use these later. Okay? Are you okay with plus or minus 1? Okay. So hold those thoughts for right now. What else do we need to use? Tangent of theta equals y over x. So, tangent of theta equals 1/2 over negative square root of 3 over 2. Yes? Now, have you guys learned when you're dividing a fraction by a fraction, the denominators are the same? What ends up happening? The 2's are going to cancel, and so really this is going to be tangent is negative of 1 over square root of 3. Okay? Now, if you rationalize that, and multiply by square root of 3 top and bottom, this is also negative square root of 3 over 3. Why might I suggest that? Because it's over there. Yes?
Yeah.
Square root of 3 over 3 is in the tangent box when theta is pi over 6. Now, what's the catch though?
It's a negative.
We need negative quadrants. Okay? That's our catch. Here's my hint. All students take calculus. Is that a decent hint? So we just said that was going to be what? Pi over 6? It's pi over 6 in quadrant 1. But I don't care about quadrant 1 because quadrant 1, everybody is positive. What are my negative quadrants? For tangent, we're going to need to know over here and over here. What are your pi over 6 angles in those quadrants?
5 pi over 6 and 11 pi over 6.
5 pi over 6? Now, why did I not do that? Oh, I know why. What's another name for 11 pi over 6? I like 11 pi over 6. But what's the angle? So 5 pi over 6 is when we go this way. What is 11 pi over 6 when we go the other way? So when you go right or up and around, you're going in a positive direction. Now we're going in a negative direction. How far negative are we going? Pi over 6. Okay. So the thetas I'm looking for here are 5 pi over 6 and negative pi over 6.
Can you put 11 pi over 6? Like, why do you have to put negative pi over 6?
That's not the right answer. I'm like, oh, that's not answering my question there. We might be able to get away with 11 pi over 6. We might. I'm trying to think why I have that. And off the top of my head, I'm not sure. And holy cow, I just looked at the clock. Just go with me for the moment, okay? I don't have a definite answer off the top of my head because I'm trying to remember. Realize we came up with 2 r's and 2 thetas, yes? Okay. This point, where is negative square root of 3 over 2 comma 1/2? That's a traditional xy point. Negative takes me left. Positive 1/2 takes me up. I need to create points that are in quadrant 2. Which of these 2 angles was in quadrant 2? 5 pi over 6, yes? If we use 5 pi over 6, are you going to be going positive or negative 1 to get out to that point? If we're on 5 pi over 6, if you're on 5 pi over 6 and you're trying to be in that quadrant, you're going to count out positive 1. Because then, where is negative pi over 6?
It would be backwards.
See, the idea is when we get to negative pi over 6, do I need a point down here on negative pi over 6? No, where's it going to go? We need it to go backwards through the poles, so we're going to use negative 1 with the negative pi over 6. Gosh dang it, I don't have time for this. I don't have patience for this, that's for sure. There we go. So 2 polar coordinates here is what we're looking at. Okay? And you're going to get 2 every time, because you can always get what it is with a positive R value and what it is if you end up in the adjacent quadrant and shoot your way backwards through with a negative R value. Okay. B, I might try to later today make a video to finish B, or I'll see what I get through in 5th hour. Real quick, distance formula. You can find it in your book, but distance formula for the distance between 2 polar coordinates. It's kind of like the distance between 2 points. D equals the square root of R1 squared plus R2 squared minus 2 times R1 times R2 times the cosine of theta 1 minus theta 2. Now, and what is that based on? The fact that one of these points is R1 theta 1 and the other point is R2 theta 2. Okay? It's a plug and chug. It really is. I know it doesn't look like that right now, but it is a plug and chug. So, thank you for bearing with me. Tomorrow, check out Schoology. Either we will have gotten through all the notes. I'm going to go and get these out. All the notes 5th hour, and I'll leave that video on Schoology, or I'll leave a separate little extra video. Okay? I'm giving you graph paper so you have it. This is for I think it's 7 and 8 and 11 through 14. There's 6 points, put them all on one graph. Okay? Good luck. Get work done. You've got lots to do tomorrow.